Jai Hind, Vande Mataram. This is Kunal Mehta from Make My Scientific, and in this video lecture we are going to derive all the equations of motion in one dimension using the calculus. So it's my humble request that if you don't understand the equations of the motion, there is a video link which is given in the description. You may want to see first that video and then understand that using graphs also you can also derive these equations. But here I am only going to restrict ourselves to grade 11 physics, that is calculus, right? So I'm using calculus to derive the equations of the motion. Before we go ahead, you must understand that these all equations will hold only true for one dimension. That means the body is moving in a straight line, and then after, the acceleration of the body is also constant. It should not happen that the body is moving with different accelerations. Then in that case, as well as if the body is not following one dimension motion, these equations can't be true. So let's go ahead. All right, so what do we have over here? We have a car which is moving in x direction, positive x direction, with a constant acceleration a, which means the velocity of the car is increasing by a constant magnitude. At time is equal to 0, the initial velocity of the car was u. It may be 0, it may be something else. At time is equal to 0, it was at the origin of the x-axis. At time is equal to t, the velocity kept on increasing and finally became v. Now, from here to here, this gap is the displacement, and you can very well see that if the car would have been somewhere over here, this point is said to be the position. So the position is changing with respect to time. So the final position, this may be called as xf, this may be called as xi, initial position. The difference between these two locations itself is the displacement s, right? We do know that using derivative, the first order derivative of displacement or the position is the velocity, and the second order derivative of the displacement, that is d2s by dt2, is acceleration. Or if you still differentiate velocity one time with respect to time, you get the acceleration, right? Now there is another version of acceleration. This can be written as dv by dt multiplied by ds by ds. That's due to the fact that this ds and ds will again become 1. Okay, so rearranging the term, this goes over here and this goes over here. This becomes dv by ds and this becomes ds by dt. So this ds by dt is nothing but the velocity. So we can also write down acceleration as v dv by ds. So this is the start and this is the situation. Now let's see the first equation of the motion. So now let's move ahead with the first equation of motion, and the first equation of motion states that v is equal to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time taken. Okay, so how would you do that? So we do know that acceleration is basically dv by dt. I'm going to take this dt on this side. So what do we get? A dt, that is equal to dv. All right, now I'm going to integrate both sides like this, and now here, since we have dv, so the limits of velocity would be here, and here, since it is dt, limits of acceleration would be there. So at time is equal to 0, the velocity was u. At time is equal to t, the velocity was v. So this is how we are going to do it, right? Now, since acceleration is constant, I'm going to pull it outside. So a integration of dt from 0 to t, that is equal to integration of dv from u to v. Now integration of dt is simply t, that is from 0 to t times a. Now that is equal to integration of dv is v u to v. Right, now we are going to plug in the upper limit minus the lower limit. So instead of t, substitute t. Instead of t, substitute 0 minus the lower limit, that is v upper limit minus the lower limit. So basically we are getting v minus u is equal to at. So v is equal to u plus at. So this is v is equal to u plus at. This is our first equation of motion that we have derived. Now let's move ahead with the second equation of motion that states S is equal to ut plus half a t square. Alright, so U stands for the displacement, sorry, U stands for initial velocity, displacement, time, acceleration, and so on. Okay, so we do know that the displacement, first integration, first differentiation with respect to time is velocity. So we are going to use this expression ds by dt is equal to v. Now simply take this on the other side, so ds is equal to v dt. Now, if you integrate both sides, here you will have to put the limits of the time and here of the displacement. So this becomes at time is equal to 0. The displacement of the body was 0 because it started from the origin. At a time is equal to t, the displacement became s. Finally, the displacement was s, right? Now, this is integration of ds is s, that is from 0 to s. Integration of dt, you can't simply pull out v as constant and pull it out, which would be wrong, because this is a function u plus at. This is a time dependent variable, so you can't pull it outside. This is from 0 to t. So upper limit minus lower limit, so it is s minus 0, so I am simply writing s. Now this is integration of u dt plus integration of at dt, all limits from 0 to t, 0 to t, right? Now what we are going to do, s is equal to u is constant. When the body started at time is equal to 0, at that time the velocity was u, and throughout the entire motion u is constant. So u will come out, integration of dt is t, upper limit is t, lower limit is 0, plus a. Now integration of t is t square by 2, that is from 0 to t. So I'm going to simply substitute upper limit minus lower limit. So ut minus 0 plus this 2, I'm going to pull it out. So a by 2, that is upper limit. So that is t square minus 0 square, right? So we are getting our final equation, s is equal to ut plus half a t square. This is the second equation of the motion. Now the third equation of motion is v square minus u square is equal to 2as. So here v is the final velocity, u is the initial velocity, a is the acceleration, s is the displacement from u to v. So at time is equal to 0 to time is equal to t, the displacement is s. Okay, so what we are going to do is, acceleration is basically dv by dt. Just before few minutes I said that multiply up and down by ds, rearrange it, so this becomes dv by ds times ds by dt. This is nothing but the velocity, so v dv by ds. Okay, so here acceleration can be written as v times dv by ds. I'm going to take ds on this side. So what I get is a times ds, that is equal to v dv. I'm going to integrate this equation both the sides. Here I will have the limits of velocity. So at time is equal to 0, the velocity was u. At the same time, the limits of displacement was 0. At time is equal to t, velocity was v. At time is equal to t, the displacement was s. Alright, since a is constant, we can pull it outside. A, then integration of ds is basically s, upper limit, lower limit. Alright, now this is v dv, so integration of v is v square by 2. Then we have u to v, and then I'm going to substitute the upper limit minus lower limit, that is equal to v square. I can pull out half common, upper limit minus lower limit, this is u square. Instead of v, substitute v, minus, instead of v, substitute u. Take this 2 on the other side, so this is 2as is equal to v square minus u square. That is the third equation of motion. Now the last equation of motion, that is the distance traveled by the body in nth second. this is basically equal to u plus half a 2n minus 1. Now we need to understand this formula. Before that, what actually this formula is trying to say to us is, suppose if I say that distance traveled, find the distance traveled by the body in fifth second, right? So at time is equal to 0, the body was here. At 1 second it was here, 2, 3, 4, and say for example at time is equal to 5 seconds the body was here. Correct. What I am trying to explain you, distance traveled by the body in fifth second, that is the distance traveled by the body in 4 seconds minus the distance traveled by the body in 4 seconds. So at fourth second the body could have been somewhere over here like this, because at time is equal to 4 seconds it was here, 3 seconds here, 2, 1, and eventually 0. So it went on in this direction. At time is equal to 5 seconds, just do minus 1, you get 4 seconds. Now this gap itself is known as distance traveled by the body in fifth second. So if I said find the distance traveled by the body in 10 seconds, so take this as 10, take 1 time less, 1 second less, this is 9 seconds, and then this gap from 9 to 10, this could be regarded as distance traveled by the body in 10th second. Alright, so what we are going to do is the following. We will take the help of the formula, that is V is equal to ds by dt, right? So I'm going to cross multiply this term on the other side. So ds is equal to V times dt. I'm going to integrate this both the sides. Since the time limits are to be taken here, the displacement limit to be taken here, the time limit would be from, now I'm saying the distance traveled by the body in nth second. So that means let the body go from time 0 to time n seconds, and then the previous second was n minus 1, then this gap itself is the distance traveled by the body in nth second. That is distance traveled by the body in n seconds completely minus distance traveled by the body in n minus 1 second, n minus 1 seconds, like this. Alright, so this total gap minus this gap is your answer. So over here, since I am being asked to find the distance traveled by the body in nth second, so I am going to take n minus 1 to n, and this also can be written as Sn minus 1 to Sn. The integration of ds is S, lower limit, upper limit, this is nth second and n minus 1th, Sn, that is the total distance traveled by the body in n seconds, and the total distance traveled by the body in n minus 1 seconds. So this can be written as u, that is integration of u plus at then dt n minus 1 to n seconds. Okay, now what am I going to do is upper limit Sn minus Sn minus 1, that is integration of u dt plus plus integration of at dt from n minus 1 to n minus 1 to n. This u is constant, so I'm going to pull it outside. Integration of dt is t from n minus 1 to n, plus this can be written as a constant, so integration of t is t square by 2, so I'm going to write down t square by 2 from n minus 1 to n. Alright, now what we are going to do is, this itself is the distance traveled by the body in nth second, and this can be written as u upper limit minus the lower limit plus, let me take out 2 from the bracket, that is a by 2, that is n square minus, this is upper limit minus, instead of t substitute n minus 1 the whole square, right? So if you simplify this, the displacement of the body or distance traveled by the body in nth second, that is u, and you may very well understand that this n and n getting cancelled, minus minus becomes plus, right? Plus a by 2, this is n square minus a square minus 2n plus 1. Again, if you will open up the bracket, this n square will go, and then what you are left with, this minus minus becomes plus and this becomes minus 1. So your final answer would be u plus a by 2. Then this becomes 2n minus 1. Right? So this is the displacement of the body in nth second, or the distance traveled by the body in n seconds. I hope that you have understood this well. If you have any doubts, please do comment in the comment section, and do see my videos regularly, and thank you very much for watching the video.